So in this video we're gonna see how we can check if a binary tree is a binary search tree or not. So as we know, a binary tree will be called a binary search tree if it follows certain set of rules. So first of all, the left child has to be smaller than the node and the right child has to be larger than the node. And also the left subtree and the right subtree also has to be one BST. That means they also should follow these two rules. Then only we can call a binary tree as a binary search tree. So like an example, here we have one tree. Now to check if that is one binary search tree or not, we can perform the InOrder traversal. So in case of the binary search tree, if we perform the InOrder traversal, all the nodes will be sorted in ascending order. Then only we can say that this is one binary search tree. So to perform the InOrder traversal, we're gonna start traversing from the root node, and whenever we reach below one node, then we're gonna count this in our InOrder traversal. So first of all we have 7, then we are below the number 8, then we are below 9, and then we are traversing and now we are below the number 10, and then we are below 14, and then 15, and then lastly we have 16. So this is our InOrder traversal, and you can see here all the numbers are sorted in ascending order. That means we can say that this is one binary search tree. So here we have the function to perform the InOrder traversal. So in this InOrder function we pass the root node, and then first of all we check if the root node is null, that means the tree is empty. So in that case we're gonna return. Otherwise we're gonna recursively perform the InOrder traversal. So first of all we're gonna recursively call for the left node, and then we're gonna print the root node data, and after that we're gonna recursively call for the right node. So in case of this InOrder traversal, first of all we have the left, then root, and then we have the right. We are calling for the left, then we are printing the root node data, and after that we are recursively calling for the right node. So here we have created the tree with all of these node data. So first of all in the root we have the value 10. So here you can see we have created one node with the value 10. So this will be the root node. Now after that root's left node will be 8 and right node will be 15. So here the left node is 8 and the right node is 15. And similarly we have defined this root left is 7. So root nodes left is 7, and similarly root left right is 9. So here root nodes left right is 9. So this way we have created the whole tree. Now let's just call the InOrder function. So here we can perform the InOrder traversal. So we're gonna call the function InOrder. So here we're gonna pass the root node. So here we have the InOrder traversal, and you can see all the values are sorted in ascending order. So that means we can say that our tree is one binary search tree. Now instead of using the InOrder function, we can directly write one function to check if our tree is binary search tree or not. So here we have this isBST function to check if a binary tree is a binary search tree or not. So this is based on the min-max theory. So as we know, all the values in a binary search tree will fall in between the range. So this is the minimum and this is the maximum value. So all the values will be in between these two range. Now we can use this min-max constraint to check if that is binary search tree or not. So here we have the isBST function. Now in the function, first of all we're gonna pass the root node, then we're gonna pass the min and the max value. So as we know, all the values of this binary search tree will fall between this minimum and the maximum value. So for this left subtree, the range will be from this minimum to this maximum value. Now for this right subtree, the range will be from this minimum to this maximum value. So this is the property of the binary search tree. Now we can use this property right here in our function. So initially our minimum and the maximum value will be infinite. In C we can use the int min and the int max. So this will be the minimum value and this will be the maximum value. So first of all we're gonna check if our root is null, then we're gonna return 1, because empty tree can be a binary search tree. Now after that we're gonna check if our root data falls between the min and max value or not. So if the root data is less than min, or if the root data is greater than the maximum value, so if our data is out of the min max range, then we're gonna return 0, which signifies that this is not a binary search tree. And then we have to recursively perform the same thing for the left and the right subtree. So here we're gonna recursively call the isBST function for the left and the right subtree. So for this left subtree, the minimum value will be same, but the maximum value will be root data. So as we have talked earlier, for this left subtree, the minimum value will be same, but the maximum value will be this root value. Now in case of the right subtree, the maximum will be same, but the minimum value will be the root data, because in case of this right subtree, the root data will be the minimum value and this will be the maximum value, and all of the other values will fall in between this range. So this way we're gonna recursively perform this check for all the subtree, and if all of the subtree follows these rules, then only we can say that this is one binary search tree. So here we can check if our tree is binary search tree or not. So we're gonna call the isBST function. So we're gonna pass the root, and the minimum value will be infinite, so we're gonna use the int min, and the maximum value will be int max. So in that case we're gonna print yes, it's BST. Otherwise we're gonna print no, it's not BST. So here it is printing yes, it's BST. So this is the way we can check if one binary tree is a binary search tree or not. So hope you understand about the working of this function. See you in the next one. Take care.